So guys, this is the other assignment that we posted for today, the Newton's second law of friction problems again. You guys should be pretty solid on these, okay? Instead of just typing like the letter here, you guys can just highlight what you think your answer is going to be. So, I mean, this one hopefully shouldn't be too difficult. What do we think 22 would be? Sorry, yeah, they're totally out of order. Well, not order, but like I said, I ripped this from a different old test. So what would this one be? Anybody want to answer? You can, absolutely. Killing it. Yep, very good. Very good. Yep, that was correct. One of the 7 that you said. Okay. Guys, so this was the friction equation that we had dealt with just on the previous assignment. Okay, frictional force is equal to the coefficient times normal force. I just plopped it into the triangle in case you had to solve for one of the others. Okay, net force is equal to mass times acceleration. Hopefully you guys know how to work the triangles, which you should, because no one has ever had questions on it. Well, just in case we have a question. All right, how these things work are, if you are asked to solve for one of these 3 variables, so if I said, hey, solve for acceleration, since that's what I need, if I covered that up, all right, what is left in the triangle is telling me the operation to use. So if I covered up A, you put your thumb over that, it's F net, the net force, over, so divided by the mass. If I were looking for mass, if I covered that up, it would be the net force divided by acceleration. Or if I cover up the top, put your thumb over that, if they're next to each other, you would multiply. All right, that pretty much works for any 3 variable equation. So here,
wait, that's actually like,
yep, it's pretty solid. So coefficient of friction, they give us here as 0.25. So you're given mu and mass. Okay, well, mass isn't anything. Mass is blah. What is mass? All the way at the top, these are a couple things. Mass times gravity gives us weight, and weight and normal force are equal. So that would be good. You can use that. What does constant velocity mean, guys? Good. The net force is 0. So that means, hey, I have a push force of 250. What would my friction force need to be? I don't even need to do math for that. 250. So with that involved and mass times gravity gives me weight, and weight and normal force are equal. I would then have friction force and normal force to find mu. All right, the coefficient. So if I cover this up, I need those 2 things. So it'd be like the 250 divided by whatever 65 times 10 is. 650. And highlight your answer. Okay. Now, there was some space here in case you needed to draw in a free body diagram, but it's really not necessarily required for that one. 26, though, I asked you all to do that because I thought it would be importante. So we got a rightward force, 385 newtons applied to a 25 kilogram crate to accelerate it across the floor. The coefficient of friction is 0.65. Determine the acceleration of the crate. Draw a free body diagram. How do I do that? Insert drawing, new. All right, and we want to label the 4 forces: weight, normal force, applied force, friction force. And then afterwards, we're going to show all the work. All right, so let me just go real quick. Insert drawing, new. Shapes and rectangle or box, whatever. And then I'm going to fill color, make it transparent. Put a little dot in the center. A circle as best as I can. All right. Now I'm just going to select over here where it says line. If I go to the little down tab arrow thing, the little drop down, there's arrow. I'm just going to draw 4 hours real quick. We got an arrow up. We got an arrow down. We're going to have an arrow right. And we're going to have an arrow left. Now, in the problem, they asked us to solve for acceleration, so I'm assuming that the acceleration arrow is going to be a little bit bigger than the other piece. Yeah, I know the circle, it's a pain in the butt to try and get everything to like line up perfect, so don't freak out though. Oh, cool. Nope, it's not gonna work. Let's see, can I move you? Can I move you? Nope. Nope. Whatever. Okay. So we can call this F sub n, which is control comma to get the subscript. Text box F sub applied. Text box, this would be F sub G for weight, and over on the left side, friction. F sub F. Jesus. Okay. So I'm just gonna then, once I get it to look somewhat like this, I'm just gonna save and close. That is not where I wanted it to go. Come here. All right, let's make it just a little bit smaller. All right. So what do we have? Let's see. Now I'm gonna move that up. All right. So we're given a rightward force of 385. So our F applied is equal to 385 newtons. What else are we given? What the French toast? What just happened? All right, so we have that. We have a mass of 25 kilograms. So we have that. Now, so F sub G is equal to mg, which is equal to 25 times 10, which gives us 250 newtons. Now, normal force and gravity or weight are equal. So Fn is going to equal 250 newtons. They give us mu here as 0.65. Nope. And our equation at the top, friction force is equal to mu times the normal force. We're given everybody that we need there. So we have 0.65. times 250 which comes out to give us a friction force of 162.5. All right. So if I have an applied force of 385 to the right, a friction force of 162 to the left, that's going to give me a net force of, why is that tiny? F net is going to be 222.5 newtons to the right. So I haven't really done too much here, even though it looks like it is. You're given mass, mass times gravity, weight. Weight and normal force is the same, so normal force is 250. This was given in the problem. So I literally took those two numbers, multiplied them together, I got friction. And then if you could write underneath these, or if you want to click and edit and write over here 162.5, 385, then it's just literally looking at the diagram. You see two vectors going in the opposite directions, subtract them. So that's how I got this. I did 385 minus 162.5 to get this as my net force. And since they wanted us to find acceleration, and acceleration is this equation here. Excuse you. All right, so now we have acceleration F net over m. We have the F net, and we have the mass from before. Just plug those into the equation. So our F net was 222.5, and I'm going to divide that by 25. And this kicks out an answer of 8.9 meters per second squared. Which leads us to say, aha, the answer would be letter A. So the reason why in these problems I asked, when I say draw out the free body diagram, because I think it visually just helps you see it, which then makes finding net force easier. All right, if you know that weight down and normal force up are going to be equal, that's perfect. They don't contribute to us finding our net force value. They told us that we had an applied force of this 385. So me, like normally I'd have this drawn underneath or written underneath as 385. Solve for friction, 162.5, boom. And then it's just simply looking at it and being, okay, there's no equation. I just know that you have two forces in opposite directions, subtract. And that helps me get this. We already given mass, boom, and solve. And again, that's just like I said before. Usually you're going to be given mass, you solve for weight. Weight and normal force are equal to each other. You use that somewhere in here to help you solve for one of the other two that you may need. In this case, it was solve for friction. We were given an applied force, which then helps us solve for the net force. And then from there, you have F net and mass. You can solve for acceleration. Okay. So in this one, you have two movers that apply 85 newtons and 252.5 newtons of force in the same direction. So what do I do with those two forces? Same directions, we do what? Add them. So what you guys are going to want to do in this one first is take these two and add them. Then that will be your total applied force to the right. Friction force would be this guy to the left. So if I have a force to the right and force to the left, what do? Subtract. That will give me my net force. and you have mass here, and then you just type it into the equation. And then the last pat here, just some true and falses. Just some true and falses for you guys to go through and use. Okay. So yeah, I think you guys should be able to crush this. Okay.
Is this confirmed?
This is due tonight. Yeah. Does anyone have any questions on this?